In this video, we're going to talk about polynomials. Polynomials are actually something we've already looked at because a quadratic is actually a type of polynomial. So the focus today will be on what a polynomial is and how to name it. So the name polynomial, basically in Latin root here is poly meaning many, nomial meaning numbers. So it means literally many numbers. But in math, it is a function that is made up of at least one term in which all the terms have whole number exponents, meaning their exponents are 0, 1, 2, 3, 4. They cannot be negative. They cannot be a fraction. They cannot be irrational. The degree is what we describe as the largest exponent of the polynomial. So in a quadratic, that would be a 2, and that's why it's called a quadratic. A term is any combination of constants or variables separated by addition or subtraction signs. Okay, standard form of a polynomial is a polynomial that is organized from the highest exponent, otherwise known as the degree, to the lowest exponent, usually ending in a constant, but not always. All right, so how do we name, and by the way, that's always descending order. Everything in math is descending order. So, at least with exponents. So, how do we name that polynomial, right? A polynomial is named first by its degree. And so you can see in this list things you recognize like linear or quadratic, also cubic. There is quartic. So we start with, if there is a 0 degree, we have a constant. A first degree polynomial, keep in mind, if you think about a linear equation, y is equal to 2x plus 3. The exponent is a 1. A constant would be something like y equals any number, so -5. And a quadratic would have a square as the highest exponent. A cubic would have a 3. A quartic would have a 4. And in this modern day and age, it's usually where we stop, but it does keep going. We would have a quintic, a sextic, a septic, an octic, a nomic, right? But typically we just stop here. If you want to learn these other ones, that's great. All right, and then we name the polynomial, then this is the first name, right? And the last name of the polynomial is based on the number of terms. So in this example, we have one term and it's constant. So it would be a constant monomial. But you could have a cubic monomial, right? You could have y is equal to 3x to the third power. And that would be named first by this. So it would be a cubic, right? Be cubic first, and then it would be a monomial because there is one term in this expression. However, if I had something like this, this would be linear first, and then notice that there is 1, 2 terms, so this would be called a binomial, bi meaning 2. And obviously it goes from there, trinomial, quadnomial, pennomial, hexnomial, hepnomial, and so on. And typically we only learn up to quadnomial. So an example of this is if I had y is equal to, we'll do a quadratic, x squared plus 4x minus 3. This would be called a quadratic, and then 1, 2, 3. The technical name for the chapter that we learned previously, this would be called a quadratic trinomial, as opposed to last chapter if we had something like this, right? This would be a quadratic binomial. All right, so I think we should just take a couple look at examples of that and how to name that, and be a good idea for our key terms. So let's take a look at this example right here. So first we're going to determine if it's a polynomial. So let's just determine if it's a yes or no, kind of like we did when we had functions, right? Does it pass the test to be a polynomial or not? So each of these exponents are whole numbers, right? These are whole numbers, so this is a yes. This one, whole numbers, even though there's a 1 there, it's still a whole number, so this is a yes. And this one also, all of these are whole numbers, so it is a yes. So to turn something into a no, let me show you a way to do that. If I did this, let's say I came in here and I made that a -8 in the exponent, right? So if that 8 were negative, or if this 3 were negative, right? So if I did this, and I turned that into not a subscript, let me fix that real quick. If it were an exponent like that, that would make it not a polynomial. It has to be a whole number. Or, right, if one of these numbers, like let's say this number right here became a decimal, okay? That would not be a polynomial. Also, if there were a square root on here, right? If you had the square root, well, square root of 4 would be 2, bad example. But if I had the square root of 3 up there, not a polynomial. Or if one of these was a square root, not a polynomial. So polynomials have to have whole number exponents and also have no radicals in them, because those are called radicals. All right, so now that we know that they're all yeses, let's write them in standard form. Okay, so to write this in standard form, this would be the first one, this would be the second one, and this would be the third one. So this would be 5x to the third power plus 2x squared minus 2x. We'll put them all in standard form, and then we'll name them. This one would be first, and then this one would be second. So this one would be negative. Notice that the negative on the 5, on the coefficient, it comes with it. They're attached. Okay, and if you don't have one at the beginning, it is always, in the absence of a minus, you have a positive. All right, so here we have a little bit more to do. So this will be first, then second, then third, and then fourth. So it would look like this, negative 2x to the 8th power minus 6x to the 6th power plus 5x third to the 3rd power, and then minus 5x. So to name them, right, we look here, right, 3, if we go back up to the chart, 3 is a cubic, so that's a cubic. And there are 3 terms, 1, 2, 3, we established that here, so 3 terms is a trinomial. So this is a cubic trinomial. Okay, so here we have a 4. If you look at the chart, 4 is quartic. So this would be a quartic. And there are 2 terms, as we established here. You can see it here, that's a binomial. The last one is an eighth. And if you wanted to, you could call that an octic. But most people, when they get above 4, they just call it like whatever it is. So it would be called an 8th degree, right? That's the degree. So we would call that an 8th degree polynomial. And then we would say the number of terms. And the number of terms here, right, we could call this an 8th degree quadnomial, right, if we wanted to. So instead of saying polynomial, we could have called it a quadnomial. But some people don't even make you learn quadnomial. Some people do, some people don't. So you could call this an 8th degree polynomial with 4 terms. Most teachers make you learn monomial, binomial, trinomial. Quadnomial is kind of hit and miss depending on your teacher, right? But definitely, so this is like the full version of it. And that's why learning the little smaller words makes your life easier. So again, if we wanted to, we could have called this an octic quadnomial, and it would have looked like the other ones. Or if you want to write it all the way out because you don't want to learn past 4, which most people don't, it would look like that.